Okay, a quick summary of what we've covered so far in differentiation. The first thing you need to know is how to differentiate. And for you to know how to differentiate, we have that rule. And a quick example is if you have y equals 2x cubed minus 4x squared. If you differentiate that, dy dx will be 6x squared minus 8x. So remember, we'll always be using that rule, the rule for differentiation. I believe everyone has the rule. If you have y equals ax to the power of n, then dy dx is going to be anx to the power of n minus 1. So this is the rule that you use whenever you're doing a differentiation. However, you have to bear in mind that whenever you have brackets, just like this case, you need to expand first before you do your what? Your differentiation, isn't it? Okay. Then the next thing that you should know is how to find gradient using differentiating. Okay, how to find gradient. And for you to find gradient using differentiation, there are two steps. Step one is for you to differentiate. Or find the derivative. And then step two, substitute the x value into your answer, into your derivative. All right. A quick overview on how you do that is if you have, okay, we might be having a question like, find the gradient all right. The browser is frozen. All right, for example, you may be having something like this. Find the gradient of this function we're talking about, y equals 2x cubed minus 4x squared at a certain point. So I'm going to write this, find the gradient of y equals 2x cubed minus 4x squared at a point 1, well, let's make it a 2 minus 5. And for you to solve this kind of a question, you need to follow the two steps I mentioned. So the first step is to differentiate. Y equals 2x cubed minus 4x squared. Then dy dx equals 6x squared minus 8. Are we all together on this one? And then step 2 is to substitute the x value. You just put in the x value. Sometimes they will give you a full set of coordinates. You'll be given the x and the y, just like what I did here. In other cases, they will just give you the x value. So if you're given a full coordinate like that, x and the y, then you just need to pick the x and substitute in. So therefore, for step 2, gradient is equal to, is given by the gradient function, which is our answer, 2x squared minus 8. And in our case, it's going to be 2. The x value is 2 minus 8. And it's going to be 0, isn't it? That's the final answer. You can use your calculator for that. 2 squared is 4 times 2, that's 8. 8 minus 8 is 0. If you have any questions, you can ask. This is the second concept we learned about. All right? And then the third concept we learned about is finding the second derivative. So let me quickly erase this. You get the second derivative when you differentiate a function twice. I'm going to show you a quick example. Okay, let me do number 4 as an example, right? So you are given y is equal to x cubed minus x squared plus 5x. And the first thing that we will need to find is, use blue. We need to find f of 1. Now, what does this mean? It simply means we need to do substitution. I believe everyone knows about functions, right? Because before we did differentiation, we looked at functions. So f of 1 simply means we need to substitute 1 in our original function. So f of 1 will be 1 cubed minus, not x, minus 1 squared plus 5 times 1. That's f of 1. And then we get our answer. Can you quickly look this up? Punch it in your calculators and then tell me the answer. Did you get the answer? All right. I'm not sure if it's bad connection or something. The answer is going to be 5. You can look it up. All right. That's fine. So now the second question is asking us to find f prime of 1. So find f prime of 1. The prime, this guy I'm writing in red, this guy looks like a power. Okay. Simply means find dy dx. The prime is just the same as differentiation, isn't it? It's an alternative way of writing dy dx. So in this case, we're going to have our f of x. So f of x is x cubed minus x squared plus 5x. Then f prime of x, which is almost the same as dy dx, is equal to 3x squared minus 2x plus 5. So we have f prime of x now. And then since we have 1 inside f prime of x, we need to do our substitution again. So let's quickly do that. So f prime of 1 is going to be 3 times 1 squared minus 2 times 1 plus 5. And if you punch that in your calculator, you're going to get 3 minus 2 plus 5. And 3 minus 2 is 1. 1 plus 5 becomes 6. So this is going to be your answer. I don't know if you have any questions for now. Are we all good? Lisa,
Yes,
if you,
sir.
okay. Lisa, if you have questions, you can just type in the chat box. Okay, now we move on to the last part. And this is the part that I'm going to expand on. I want you to find f prime prime of, according to our question, 1 again. So whenever you have these two primes, or these two powers, it's not a 1, it's just a prime. It's just a line, okay. It means you're differentiating twice. So for you to get f prime prime, you need to expand on f prime. So I'll start here at f prime. F prime of x, which is our dy dx, we found it to be 3x squared minus 2x plus 5. Now, f prime prime of x will be 6x minus 2. So what we did is differentiating the original function twice. So this is the original function. If you differentiate it the first time, you get f prime of x. So that's the first time. And then if you differentiate it twice, you get this one, second time, all together. So whenever you have this guy, f prime prime, you must know that you must differentiate a function twice. But now, what we need to understand is after f prime prime of x, they have this 1 functional notation. So we must replace all the x's in f prime prime of x with 1. So f prime prime of 1. The x has been replaced by the 1. I'm sure you can see that. So now what we need to do is we'll be having 6, and then 1 minus 2. And then the final answer is going to be 4. Are we all together on that?
Yes, sir.
All right, Melissa?
Yes, sir.
Maya? If you're confused, you can tell me so that I explain.
Yeah, can you spell that?
You want me to explain which part?
The F prime.
The f prime. Okay, so this guy.
I mean, from F prime.
Okay, from f prime here, from here.
Yeah.
Okay. So what we did is, in the question we were given f of x. I'm gonna write f of x in black. And let me quickly erase everything, these answers like from the previous one. So when you watch the video, you can always rewind and take some screenshots and then pause the video and stuff. Okay. So our original function had this guy. F of x is equal to, let me look it up. It's not this one. We're doing number 4. So our original function is f of x equals x cubed minus x squared plus 5x. All right. Okay. So what you need to understand is whenever we're differentiating, we need to use the same rule, the rule I told you, right? So if we use that rule on x cubed, the 3 is gonna fall down. We have the 3 here now. And then we reduce the power of the 3 by 1. So now we have 3x squared. This is known as the first derivative, and we have to do it for all the terms. Are we together?
Yeah.
All right, so if that's a 5, I believe maybe it was a 5x there for us to get a 5. So if we differentiate this black function once, or if we apply that rule, we get what we call f of x, f prime of x. This is the same as dy dx. But in this case, they didn't want us to find the f prime of x. They gave us 2 primes, right? They gave us these 2 guys, this guy and this guy. So what you need to do is, once you have your initial answer, you need to differentiate it again. So let's focus on this 3x squared. If you differentiate it again, 2 must fall down, and it becomes 2 times 3. That will give you 6. And then we reduce the power. The power was 2, now it's 1. And then we'll do it again for the next term. So you're differentiating twice. And I urge you to watch the other differentiation video, and then maybe you can contact me after the lesson, because we don't have much time. I just need to introduce a concept in 5 minutes and I will be done. Okay, so what we're doing is differentiating a function twice. All right, so now let's look at the last and the final part of differentiation according to your syllabus. So we're done with the first one, the second one of just finding gradient. Now we need to know the essence of the second derivative. Why do we really need to differentiate a function twice? Okay. So whenever you want, let me quickly do this and reopen it. Okay. So why do we need to differentiate twice? So why find d squared y dx squared, or f prime prime of x? So the whole reason why we do that is it gives us the nature of the what? Of the turning point. Remember yesterday I told you that if you find dy dx, you equate it to 0 and solve the equation, you are going to find the turning point of a curve. Then, if you differentiate twice and plug in that turning point, you will find the nature of the turning point. Now, let's look at this. We're going to use a very simple function. So find the turning point of y equals 3x squared plus 4x. This is a quadratic equation. We know it has one turning point, right? And then for part B, determine its nature. All right. So that's fine. So now let's do this. Right. For the first step, it's going to be easy. Let me make it this way. So number 1, finding the turning point. The turning point is the TP, right? And for you to find the turning point, you need to solve dy dx is equal to 0. Okay. So now in our case, y is equal to 3x squared plus 4x, and dy dx is going to be what, Boipelo?
X plus 4.
Yes, 6x plus 4. Okay, so this is just a gradient function. But we know that at the turning point, the gradient is 0. And if we want to find the turning point, we just need to solve this part. So therefore, 6x plus 4 equals 0 at the turning point, right? Now let's solve this to find the x value at the turning point. So 6x equals minus 4. X equals minus 4 over 6. So this is the x value of the turning point, right?
Yes, sir.
And yesterday I said that you must also find the y value of the turning point. Find the y value. And for you to
To
find...
find the y value, so to find the y value, would you take your initial equation at the top, which is y equals 3x squared plus 4x, and plug in your x value?
Yes, that's correct. So that's fine. I'm going to write the original equation. Y equals 3x squared plus 4x. And then I'll plug in our x value at the turning point. So y is going to be 3 minus 4 over 6 squared plus 4 minus 4 over 6. Okay. We don't care about evaluating that, but I just needed to remind you on that, right? Okay. Now let's move on to the second part. We want to determine the nature of the turning point. So we know that our turning point is at x is equals to minus 6 over 3. So determining the nature will require you to differentiate twice or to find the second derivative. So to determine the nature, step 1, find d squared y dx squared or f prime prime of x. And then step 2, substitute the x value at the turning point, right? Or the x coordinate. All right. So are we together? This is going to be very easy. Okay. And we have 2 minutes to just finish that. So our y was 3x squared plus 4x. And we found dy dx to be 3x squared, no, to be 6x, to be 6x plus 4. Now let's find d squared y dx squared. So in our case, when we differentiate the function again, what are we going to get, Melissa? Yes, the answer will be 6. Can you see that we don't even have a place to plug in our x coordinate? There's no need for us to go to step 2 to plug in the x coordinate because we don't have an x element there. Right? If we had an x element, we were going to proceed to stage 2. So since we don't have the x element, we just leave it as it is. So now after substituting your x coordinate, if your answer is positive, it will be a minimum turning point. And if your answer is negative, it will be a maximum turning point. Are we together? So here in this case, since d squared y dx squared is positive, this is a minimum turning point. In other words, I can predict the shape of this curve is going to look like this. This is a minimum turning point. Right? It's a smiley face. if we had done our substitution, maybe suppose our answer was 6x, and then our x value was -1, we're going to get -6. Then, in such a case, your answer would be negative, and then that will give you a maximum turning point. Are we together?
Yes, sir.
So you just sub in the value of x in your second derivative. If your answer is positive, it's a minimum turning point. If your answer is negative, it's your maximum turning point.